Hello students, welcome back to Adamya Education. Yesterday I came across a question which a student had sent me. This question is from calorimetry class 10. So let's solve it.
So let's read the question first. A child running a temperature of 101 degree Fahrenheit is given an antipyrine, a medicine that lowers fever, which causes an increase in the rate of evaporation of sweat from his body. As we all know that when we have fever, the more the evaporation, the quicker we get well. So our question is related to that. If the fever is brought down to 98 degree Fahrenheit in 20 minutes, what is the average rate of extra evaporation caused by the drug? Assume the evaporation mechanism to be the only way in which heat is lost. The mass of the child is 30 kg. The specific heat of the human body is considered to be approximately equal to that of water. And the latent heat of evaporation of water at the temperature is about 580 calorie per gram. So we are going to solve everything by using the CGS unit. So let's start. Okay, so let's get started. The initial temperature of the boy is 101 degree Fahrenheit, so we are going to convert it into Celsius. So I'm showing you the calculation later on. First let's just write the values given. And the final temperature after the fever has gone down is 98 degree Fahrenheit. So we are going to convert everything into the CGS unit. We can convert it into any unit you prefer, but here I'm just converting everything into the CGS, which gives 36.66 degrees Celsius. So the formula which we used is a very simple one which we have learned since years, is F minus 32 by 9 into 5. So using this formula I have converted this. So now we are going to find the change in temperature or the decrease in temperature. We are denoting it by delta T. So 38.33 degrees Celsius minus 36.66 degrees Celsius, which gives us 1.67 degrees Celsius. Now we are going to write the mass of the boy, which I am denoting it using M. So 30 kg, which gives 30 into 10 to the power 3 gram. And the specific heat of human body was equal to the specific heat of water. So as we know, the specific heat of water is, in CGS of course, is 1 calorie per gram per degree Celsius. So we are taking it in this way and we are denoting it as C. So a very common formula which we have, heat lost or gained by any object. So you have to get thoroughly revised with the formulas given in your chapter so that you can solve these type of questions. It is very easy. You have to just understand the question well and then proceed. So heat lost by the child will be mc del T. So let's just put the values. Which gives us almost 50,000 calorie, and this occurs in 20 minutes according to the question. Just check it out. Okay, so we have got the heat lost in 20 minutes, but we need per minute. So what we are going to do, a simple unitary method calculation, we are going to divide it by 20. So heat lost in 1 minute will be equal to 50,000 calories by 20 minutes, which gives us 2,500 calorie per minute. Okay, next we are coming to the main part of our question, which has been asked, the average rate of extra evaporation caused by the drug. So our required answer will be, which is the average rate heat lost per minute by the latent heat, which has been provided in the question. So 2500 by 580, which ultimately gives 4.3103 gram per minute. Okay, so let's derive the formula which we previously used. It's a very simple one. As we know, the latent heat is equal to the amount of heat divided by the mass, and hence we can write M is equal to Q by L. Now if we divide both the equations by T, what do we get? M by T is equal to Q by LT. So we had already found this part, which was the heat lost in 1 minute. So we are simply dividing it by L to get the required answer. I hope it helps you students, and don't forget to send your questions in the email given in the description link. Thank you.